Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 18th. First up, we take a look at significant wave heights for the North Pacific Ocean. We see two tropical systems in play. First, Olaf, here about midway between Hawaii and Mexico. Sustained winds, 70 knots, moving on a northwesterly track and forecast to turn to the north. Could be an interesting situation. Over here, Typhoon, actually Super Typhoon Champy, winds just Typhoon Champy, winds 125 knots. It's pretty much peaked out. It's forecast to recurve to the northeast. Another tropical system off the charts here, formerly Typhoon Kapu, and then another low pressure system in the Gulf of Alaska. First glances suggest the North Pacific storm pattern is improving. As usual, first we'll take a look at jet stream level winds. These winds help support the formation of gales and/or storms, and when those storms do form, help direct their track. Currently, we have a decent, respectable jet stream flow, somewhat a little bit ragged here, pushing off of Asia, but then consolidating nicely over the dateline, and this has sort of been the pattern for the past couple weeks. Looking good here, a bit of a trough. That's a dip to the south. That helps support counterclockwise circulation in the upper atmosphere, and we in fact see an upper level low right in this area. Anyway, and so we have a trough here on the dateline, and then decent energy, not particularly, particularly powerful, but little pockets here of 120, 130, even 140 knot winds. Then the jet stream splits right off the U.S. west coast, part of it, of course, running into Canada, the other part down into Mexico. Let's put this into motion, see what happens. We see that trough holding reasonably well, getting a little bit better support here on Monday night, pushing towards the Gulf of Alaska, and then another pocket starts developing here west of the dateline on Wednesday and builds. This is actually getting, look at this, 190, almost 200 knot winds, and almost the beginnings of a decent trough forecast here. And as we roll out in time, sure enough, look at that, a pretty good trough right here come theoretically Friday night into Saturday. Look at that. That would be a legitimate, I would call that the first legitimate real trough of the winter season and in the Gulf of Alaska. And you know what? This whole thing at this point looks pretty El Nino-like, because the whole jet's down here about 40 north and basically just running flat west to east and aligned very much in what we'd call an El Nino-like pattern. Anyway, that trough continues. Good support, even 140, 150 knot winds into Sunday, and then it sort of, fades out. But then it looks like there's yet more support building back here west of the dateline for another trough. So this looks promising. Next, let's take a look down at the surface. As expected, broad area of low pressure here over the dateline, and then our two tropical systems, Olaf and Champy, and then Kopu pretty much out of the picture there. Let's put this into motion. We follow the first low, and it's theoretically supposed to build a little bit here on Tuesday. And sure enough, there we go. A little patch of 45 knot winds aimed pretty well at Hawaii, but also at the U.S. West Coast. And that's pretty much through the day Tuesday, 40 knot winds. That's pretty interesting. Also notice Olaf heading northwest. And this system here, let's see where that's heading. It's heading north. Okay, gosh, lot 1, 2, 3, 4 systems on the charts. This one probably not doing much in terms of swell generation, maybe wind cell for Hawaii, but the others, we're going to keep our eyes on it here. We roll this out, and then we'll just see, here we go, watch this on the dateline. Oh, actually, this system does blow up a little bit come Thursday night. Not doing a whole lot. It's mainly this one here, 40, 45 knot winds. And notice here, Champy starting to head northeast, and at the same time you have Olaf heading north, and all just looking like they want to converge somewhere in the Gulf. Look at this, a broad fetch of 40 knot winds aimed right at the U.S. West Coast. Classic kind of pattern right there, with backups coming in from the east from Champy, and then Olaf heading off to the north. This is on Saturday. A little bit of hype probably here in the models, but then here you go, 45 knot winds on this system, and we're over the dateline with it. That's sort of a milestone too, and yet Olaf still coming in from the north, and here we are at 180 hours out. It looks definitely like a swell generation machine setting up in the Western Gulf, and that's exactly what one would expect if El Nino were in play. And then, of course, there's this whole bit with Olaf. We had a system similar to this that did one of these sort of things, got us a pretty decent-sized swell swell here in Central California a week ago. They're, 3 foot overhead, maybe on the peaks, from the southwest, like 250 degrees. So there's that, and all this. The outlook in general looks very favorable if one is to believe the models. So let's take a look at what effect those winds will have on the ocean surface. Here's our wave model, significant sea height or wave height, that is. So this is actually a model of a model. Winds from the GFS model, roughly speaking, superimposed on the ocean, and then as those winds blow, it simulates the effects of what traction those winds have on the ocean surface and what seas they generate, and that, of course, produces raw swell, which then radiates towards one of our breaks here or here and creates surf. So, as we saw before, low pressure up here over the dateline, small seas, what is that, 14, 15, 16 foot, something like that, nothing really particularly interesting. And then our 2 tropical systems. Let's put this into motion. As we roll through, this dateline system doesn't do a whole lot, but then some of that energy starts consolidating up here come Tuesday. And sure enough, we saw there was, 40-knot winds, and there you go, 20, 22, 24-foot seas. That's good for about a 14-second period. And then this goes up to 26 foot. So this is the most aggressive or positive run of the models we've seen. We've been watching these systems. This is generally being considered to have maybe 22 or 23 foot seas. Now they're saying 26. Let's assume that to be true. That would make a swell in the 15-second period, certainly coming into the Pacific Northwest and Central California. Probably a little bit overhyped, though. And then, of course, our 2 tropical system. We're just sort of ignoring that right now. This guy holds on nicely into Wednesday morning and then starts fading out. Remember that 4th little low we saw here? Yes, it's there, getting no traction on the ocean surface, not really doing anything initially. And then here's our north dateline storm. We're very interested in that, and that guy starts blowing up come Friday with 30-foot seas. That's good for probably 17-second period, but it's a long way from both Hawaii and U.S. West Coast at this point in time, so that swell would be small. Anyway, we roll this out, and this guy, actually, notice this too. This is Champy heading off to the east, and then Olaf to the north, and then boom, this guy starts blowing up on Saturday, supposedly 32-foot seas, and that's about it. 32-foot seas, but for the better part of, let's say, 24 hours, aimed well at these targets here. Sideband energy mainly down to Hawaii, but most of this fetch is aimed towards the U.S. West Coast. That's good for 17-second period energy, if one is to believe the models. And then we got this guy coming in, Champy, over the dateline, smaller fetch area, but still, 30-plus foot seas. Whoops, and that was the end of that. And then Olaf again. The short of it, the picture looking far more improved than anything we've seen so far this fall. This is kind of what we would expect if El Nino were in play, is to see this kind of a dynamic. And our El Nino has been maddeningly slow in developing, but it is getting steady, consistent traction. Water is warming down here. We'll get into all that in a minute. But the short of it is the ocean and the atmosphere above it will respond in kind. If the El Nino character is slow and takes a while to get going, then one would expect that the storms in the Gulf and over the dateline would be slow to develop as well. But once they get going, once the pattern sets in, it isn't going to stop anytime soon. Let's take a look at the southern Pacific. So here we go, significant wave heights for the South Pacific Ocean. We're going back in time. Actually, let's talk. There was even another system before the one we're getting ready to discuss. Swell from that one is hitting Hawaii, working its way towards the U.S. West Coast. That from a small gale that was here under New Zealand, better part of 8 days ago or so. 38-foot seas, kind of aimed to the east. But Hawaii actually got up here. Hawaii got better sized surf than was expected, more swell. So likewise, the expectation is California might do reasonably better Monday, Tuesday, Wednesday sort of time frame, but nothing huge, just something rideable. Anyway, so here we go. Now we're to Thursday of last week. Yet another system, basically in the same area, develops, only this one more intense here with 46-foot seas, and a little bit more. It went to, 48.5-foot seas over, one tiny little area. This is what, a half a degree, so it's 30 square mile blocks, basically, 30 by 30. So anyway, And aimed a little bit to the northeast, so that was on going into Friday, and then the system started fading from there, but sort of drifting to the northeast. So the point being, another pulse of swell is expected for Hawaii about a week out, so that'd be next weekend, and the U.S. West Coast probably late in the weekend into early the following week. But by then, the North Pacific's going to be blowing up, and Southern California might be shadowed from some of the activity that's going in the north, so they'll certainly see this, and the South Shore of Hawaii also will see swell from this system. Let's go take a look at the forecast. So here we are, Sunday, current. This is the remnants for the system we saw under New Zealand. Yet another system trying to develop under New Zealand, but we're going to just spoil it here and say the pattern starts rapidly falling apart, and really not a whole lot is expected over the coming week. But we'll roll this out here so you can sort of see what's going on. And there we go. We're at 180 hours out. And as would be expected for this time of year, things go to sleep. We've actually had a really good run of consistent activity under New Zealand for the past month or so. Being how we're all, halfway to Halloween here in October, it's no surprise that things start quieting down, especially as the North Pacific starts coming online. Who really cares at this point? And now, El Nino 2015, the wrap-up for that. All the details of what's going on our developing strong El Nino, working its way, or trying to work its way, towards super El Nino status. But we're not going to buy into all the hype quite yet. And as we've done in the past, the format of the presentation will be first focusing on winds in the Kelvin wave generation area. Those winds, if they're westerly, help create Kelvin waves. That is a pocket of warm water that travels under the equator, the whole way over to Ecuador, erupts there, and so we'll talk about subsurface temperatures in this area between the Kelvin wave generation area and Ecuador, and then erupts to the surface, warming surface water temperatures, and then trades then push those warm waters into the region called the Nino 3.4 region, which is roughly from 170 to 120 west, 5 degrees each side of the equator. And if that area warms, then that helps set the atmospheric dynamic. It changes the atmosphere above that pocket of warm water, creates more precipitation, alters the jet stream, and feeds the jet stream so that in the winter months, fall and winter months, over the Gulf of Alaska and the Dateline, helps support storm development in that region. That, of course, is what makes giant surf during strong El Nino winters. Current situation, this chart, surface winds, surface temperatures, we're ignoring the temperatures, winds, and this is just a very high-level chart, but clearly west winds blowing to about, let's say, 165 west. Hawaii's about over at 155, 160. So a bit west of the dateline, west winds in play. And then here's the anomalies, differences in normal for this time of year. Clearly, west winds, west anomalies, well in play. This is exactly what you want to generate Kelvin waves. And then basically a neutral pattern across the rest of the East Pacific. So here's a zoom in. This is the Kelvin wave generation area. This is surface level winds. So basically north of New Guinea, about 135 east to the dateline, actually to about 170 west. If you get west winds or even slack winds, normally in this area is trades blowing out of the east, 10, 15 knots, maybe more, okay? But when you get slack winds like that, that creates what's called westerly anomalies. And that's enough to start taking warm water that's normally in this area and pushing it off to the east. So this pattern, see these west winds up here, and it's only from 5 degrees north to 5 degrees south. These west winds were all down in this region a week ago. We've had massive westerly wind bursts going on since October 1st, and it actually started before then, but for the past 18 days, it's been non-stop west winds pretty much the whole way across the northern part of the Kelvin wave generation area down into here. We believe another significant Kelvin wave is in flight, but we'll get into that in a minute. Anyway, looking at the forecast, what we're looking for is west winds. We see sort of this southeast wind thing going here. There's little bits of west winds here, but generally, as we roll this out, you'll see that the pattern is a little bit of trades here. Finally, what is that? In the 12 knot range. And then as we get further out into it, that starts weakening out. And then you just end up We're almost there. You get into this dead wind flow pattern. Look at that. Here come westerly winds again. Oh, about a week out. Not strong, but I'll tell you, if you just have dead winds, that's the equivalent of westerly anomalies. And if you actually have west winds at the surface, like here at 10 knots, that almost, if it holds on, would be a westerly wind burst. And there's some suggestions on some of the models that that might be what will happen. But if nothing else, the forecast for the week is generally a dead wind pattern. Not surprising. Still westerly anomalies, typical of El Nino, when normally you'd have strong trades in this entire area. Here's another chart. This is actual anomalies up at the 850 millibar level, which is about 42 to 4,400 feet above sea level. But still, it's a good proxy for what's going down at the surface. Kelvin wave generation area starts right about here. You can draw your little box right here. And this is the October 12th, 13th. And what do we see? Non-stop strong westerly winds all in that region. Then finally you get to the 16th and things start weakening a little bit. But clearly there's been a lot of westerly winds, or at least anomalies, but actual westerly winds in this area. Here's yet another way to look at it. So this is back in time, September 18th. This is the whole globe here, but the Kelvin wave generation area runs roughly, draw a line down here to about here, you know, and oranges and reds and whites or purples are these are westerly anomalies. These whites are actual westerly winds. You got about October 1st, and then you turn into legitimate full-on westerly winds. And we'll just look at this. Look at this pocket here. This just went nonstop from roughly October 1st to maybe yesterday or so. Strong westerly winds. And here's the interesting part. Again, we were talking about, then we get into just a day or two out, westerly winds or anomalies start again. This is a full-on westerly wind burst, a significant one at that, rivaling the westerly wind burst from late June, July timeframe, and we'll show you that in a second. And here we go with yet another one going on. This is classic, strong El Nino pattern. So here we go, kind of a convoluted. Here's a picture, but here is the current westerly wind burst that just wrapped up. Here's a giant one that occurred in the late June, July timeframe, scaled exactly the same. So you can just about compare size. The color scales are a little bit different, but roughly, when we did this last week, so I'm not going to get into too much of the details, but the duration roughly from there to there, and then you get down to here. This one is more concentrated, doesn't cover as long a time span as the June-July one does, but more concentrated, stronger, and continuous. A more clean, I'd call it, westerly wind burst in this event. And let's be clear, this westerly wind burst event created a massive Kelvin wave. We are beginning to suspect that yet another massive Kelvin wave is in development. And yet another way to look at the historical picture in regards to winds in the Kelvin wave generation area. So this is another one, again, July going to current time here. And then what we're looking at is, if you see blacks, that's supposedly the MJO, these black circles, but they're really not. The MJO is in effect. The reds are, the red is wind, westerly winds. Blue would be easterly winds. This is in the Kelvin wave generation area. The low-pass filter is the purple here, is the El Nino base state. Of course, you see all the tropical cyclones. The reds are equatorial Rossby waves, and you see the dark reds in the wind here, the wind anomalies, all pair up pretty well with bursts, especially here, of Rossby waves. So it's the Rossby waves interacting with the El Nino base state create the strong westerly anomalies. And so let's see, here we go. We'll just scroll down. Here we go. So here is the current Rossby wave, and here is the westerly wind burst it created. Now here we go. Here's current time right here. Here's the outlook for a couple of weeks. Westerly winds, strong westerly winds here, or westerly anomalies, and bordering on westerly winds here, come about a week and a half out. Again, now this says not Rossby wave related, but the MJO, active phase of the MJO, that is absolutely not true. The MJO is nowhere near developing. MJO is depressed. The Madden-Julian oscillation is depressed typically during strong El Ninos, and we're in a very strong El Nino now. So this is more a manifestation of just El Nino and its strength and its impact on the charts. All right, now another version. You've seen this before. Oranges and yellow, westerly winds, Kelvin wave generation area, pretty much right down the middle of the chart. This is, and bright reds are westerly, actual westerly winds, not just anomalies. Here is the big westerly wind burst, the last big one, number 3, that occurred in the June-July time frame. Here is our current westerly wind burst that just wrapped up, actually longer in duration. Doesn't look quite as intense on this view. Okay, and then the forecast. But we're not going to get into that. First off, MJO. Active phase of the MJO supposedly associated, and this is probably the last one, but it shows it here as well, though we don't believe that at all. We saw no signs of it. But this was the last really active phase of the MJO in the June-July time frame that created that westerly anomaly. This is just basically El Nino pumping, creating the most recent westerly wind bursts. And now we see continued westerly winds, though weakening, a supposed inactive phase of the MJO in the late October, early November timeframe, and yet another supposed active phase. We don't buy any of that. The point being, westerly winds sort of back off, or westerly anomalies weaken in the early part of November, but then when you get to December, they're forecast to pick up again. And that is attributable to, yes, the El Nino base state here. Notice the density of isobars increasing, but then on top of that, we'll throw in the Rossby waves. Things get very busy, but again, Rossby wave, strong westerly winds, Rossby waves, strong westerly winds, and notice just about every one of these dark patches are associated with a Rossby wave. Here's another little bit here, and then we go through sort of a drought, and then things get interesting here. The other part also to notice is that come the January time frame, that the core of the westerly wind starts veering off to the east, and that's what one would expect. At some point, El Nino collapses. The westerly winds start moving out of the Kelvin wave generation area, which means they're still present, but they can't generate Kelvin waves, which means no more warm water can be transported towards Ecuador, and that sort of then warm water starts dissolving in the Nino 3.4 region. The atmosphere starts collapsing. Though there's piles of momentum, I mean, that's not to say that El Nino is dead in January, far from it. Atmospherically, it's probably almost a 2-month delay. So think of it this way. Westerly winds create a Kelvin wave. Takes 2.5 months for the Kelvin wave to reach Ecuador. It erupts. Then it takes another month for that warm water to make it into the Nino 3.4 region, and then takes another month off that for the atmosphere to start responding, if not 2 months. So if we have westerly winds into January, we're good for the Gulf of Alaska firing nonstop into the April-May time frame. And the reality is, if it's a strong El Nino, it's going to continue going the whole way through the summer, probably into next fall. So, and this is a strong El Nino. Of course, we're way ahead of ourselves. Never believe a model that far out. But anyway, it gives you sort of a sense of what is to come. Anyway, next, subsurface. We've covered all the wind thing to death. Let's talk subsurface. Westerly winds or westerly anomalies take warm water, normally in the West Pacific, push it to the east. Sure enough, here's actual water temperatures. Look at this big pocket of 29-degree waters, and the 28-degree isotherm is pretty much where so you're looking at depth from West Pacific to East Pacific and down over the equator. Large pocket of warm water moving to the east, and we've been watching this line here, not so much this one, but this line creep east and east and east, and it's about a degree every 2 or 3 days. It just suggests lots of warm water is in motion. But the more obvious thing here is anomalies, differences from normal. So there's a series of buoys, the TAO array strung across the equator. On the anchor lines are sensors, and that's how they're gathering this data. And clearly we see a large pocket of 6 to 7 degree anomalies above normal working their way towards Ecuador. The date line is off, where is it? Right there. International date line, okay? And basically, the area from the date line to Ecuador, that's quite a lot of distance. Thousands of miles are basically under the surface, way warmer than normal, and cooking warm, so 6 and 7 degrees Fahrenheit is all double that, roughly, centigrade. So let's say 10, 12 degrees above normal temperatures, subsurface over thousands of miles. That's going to have an impact. Here's a higher res view of that situation. Here's the big Kelvin wave. This is actually this is two different Kelvin waves together here. Whoops, and it's slowly picking through, but you'll get the picture here. So Kelvin wave 2, Kelvin wave 3. You can see back in the August time frame there was a bit of upwelling phase of the Kelvin wave cycle here, preventing warm water from working its way in really well into the Ecuador region. The eruption point has been west of the Galapagos and continues to be that way. You can actually see the warm water starting to hit the surface in this region. Also notice here warm water from westerly winds here in the Kelvin wave generation area falling to depth and working their way off to the east. So, and as we get into late September, October, from the most recent westerly wind burst, notice warm water building very strong out in this region. A very good sign the next Kelvin wave is under development. You've seen this chart before too. This is from the Jason 2 satellite. Basically, you look at, here's US, South America, Australia off in here, and basically you strip away all the waves, all the tides, all the wind chop, everything, and you get a profile of either water surface heights being below normal or above normal on the equator from the dateline into Ecuador. Clearly very much above normal sea surface heights, suggesting lots of warm water at depth. Warm water displaces, expands, and therefore creates sort of a bulge in the ocean surface. The cool thing is, this chart was published on October 10th. It did not have this pocket here. It's recently been updated. Now we have 20 centimeter above normal anomalies at the peak here. We barely had that in Kelvin wave number 3. So that's a good sign. Plus, just basically more data suggesting not even distinct Kelvin waves anymore, just a massive subsurface reservoir. And the more west winds you get, it just keeps pumping more warm water into the reservoir, and then that reservoir starts erupting off in this area. And then another version of that, but this is based on upper ocean heat anomalies. Differences in normal temperature-wise in the upper 300 meters of the ocean, West Pacific here, East Pacific here, time going down the scale. First a Kelvin wave. This is from the false start El Nino in 2014 in November, December. Upwelling phase of the Kelvin wave cycle. Then, boom, Kelvin wave number 1 there in February. Kelvin wave number 2 in the May-June timeframe. The massive westerly wind burst in June, July, made Kelvin wave number 3. And now look at this. We go right down here. See that bulge there? This is the start of Kelvin wave number 4. Also notice the deep 2 to 2.5 degree anomalies building. All the different temperature levels are building back off to the west. And if we were to guess, somewhere down here in the next month, we're going to start seeing 2.5 degree anomalies again in this region, suggesting much warm water at depth. All right, so the effect of those Kelvin west winds, Kelvin waves, erupting in the Galapagos area, creating a pool of warm surface water, warmer than normal water, going from Ecuador the whole way out to the dateline. The main area we're concerned with, 170 west to 120 west, 5 degrees either side of the equator, right here. We don't really care. This all looks very impressive here, but it's out here that seems to have the most impact. That's what NOAA defines as the Nino 3.4 region. That's where they're monitoring temperatures. And certainly things look very good there. Actually, things are looking much better, improved in the Nino 1.2 region, and here even west of the Galapagos. This is a low-res image. And sure, lots of warm water off the U.S. West Coast, not attributable to El Nino directly. This is a change in the Pacific decadal oscillation. We're not going to get into it, but the short of it is, as storms start building here in the Gulf of Alaska and coming across the dateline, you'll see just like there, it's going to start mixing the surface up, but all this stuff's going to disappear. Still, there's a vast pool of subsurface warm water here too. Ocean temperatures are expected to be much above normal for better part of all of the winter, but there's lots of talk about the blob and blocking precipitation coming to the U.S. That's all nonsense, and we don't believe any of it. Now here's the high-res version of that chart, and here's where things really tell. You notice it doesn't look nearly as warm here in the Nino 1.2 region as the previous image. Yeah, there's warm water here, but really the warm water starts at the Galapagos and works its way west, and you actually see embedded little pockets of 4-degree anomalies in this region, and this is what we're most interested in, looking very solid indeed. And here's the zoomed in view. You can definitely see little bits of coolness here east of the Galapagos. Not so impressive, but I don't care. You know, really, this is not the area that we're concerned with. It's off here. And here we see 1, 2, 3, 4 little all shades. I mean, it was much stronger. We saw much more warmth in this area. Oh, maybe 20 days ago, but still, definite pockets of 4-degree anomalies and lots of 3+ degree anomalies in this area. Very strong indeed. Here's the trend over the last 7 days. Differences just in the past 7 days. A little bit of warming here actually east of the Galapagos. A little bit of cooling here off south of Mexico. But again, warming out here towards the date line, and that's actually what we want to see. The Nino 3.4 region, draw a box right in here. Boom, 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 like that. All we're seeing is warming or neutral in that whole area. That's exactly what we want to see. A quick zoom in by the Galapagos. Yeah, here's a warm pocket here. Looking respectable. It was much warmer actually, like, oh gosh, in September 19th is about when things peaked out here, and it just hasn't regained since. But again, we don't really care. Here's the core area from about 95 off to 160. Very solid, all 2.5 degrees or above, but not to 4 degrees. Very just impressive. And then finally, the final little quadrant here, the date lines here. So warm water working out past, even beyond the Nino 3.4 region. This is exactly what we want to see. We want to keep it nice and cooking warm out here as well to help support atmospheric enhancement. And again, Kelvin wave generation areas over here. All the warm water would be here falling to depth. Actually, yeah, out in this region, pushed by westerly winds. And again, back to this final image, actual water temperatures, we don't care so much. Anomalies, differences in normal from the surface. Actually, we're not even so concerned with this image anymore. We like those high-res images better, but clearly you can see 2.5 degree anomalies from, here's 120 from right here out to 170s here. This is very impressive indeed. And finally, the effects of the warming Nino 3.4 region on the atmosphere. This is the Southern Oscillation Index. We're trying to measure coupling. How well is the warm water on the equator impacting or affecting or bonding with the atmosphere above it? Differences in pressure. These are historically used data points or coupling indices, if you will. Differences in pressure between Darwin and Tahiti. Negative numbers represent at least the active phase of the MJO. If they proceed long enough, then they represent El Nino. What we're really interested in here is a peak negative, whoops, we kind of went past here, peak negative number, minus 49 here. This was back in October. Then we got another nice little pulse of minus 42s here just October 14th. So daily numbers now rising. High pressure is kind of weakening over Darwin, and low pressure is fading over Tahiti for the moment. No, that's expected with Rossby waves starting to die out, all that sort of thing. Minus 1.2. The 30-day running average at a new negative low here, it got down to minus 22.65. That was the lowest it's been so far from this ENSO event. And the 90-day running average, that's 90-day negative numbers here at it peaked at minus 19.28 for 90 days. That's the average. That's exactly when this goes to minus 18 and holds. That's what you want. So we're in that range right now. This is exactly where you want to be if you're into a strong El Nino. I don't remember what it was in 97, which was pretty much the strongest El Nino on record, but it was in this ballpark area. So that's exactly where we want to be. Another index similar to the Southern Oscillation Index is the ESPI, but instead of measuring differences in pressure, it measures, here we go, rainfall anomalies. You'd expect to see less rainfall here, more rainfall in this region during El Nino. The image clearly suggests it. They've assigned an index number, 2.37. That is a very good number. Positive numbers, the more positive, the better. The highest we've seen it, I think it was up to 2.5 a couple months ago, but it's just been consistently in the 2 or higher range, which is exactly what we want to see. And this is bordering on what we saw during both the 82 El Nino and the 97 El Nino. The two strongest El Nino, both were super El Nino status, and so we are approaching that as well. There are other indexes to look at, but they're only updated monthly, so we're not going to rehash the same ones we saw. But anyway, just to put things in perspective, here's the 97 El Nino. These are sea surface temperatures, the most conservative view, but probably the best view. 2.32, peak of the 82-83 El Nino was 2.21. We're currently at 1.67. That is monthly data from September, but it suggests already at that point in time we were the 6th strongest El Nino on record, but that we suspect those numbers are only going up, and here's why. So here is the Nino 1.2 region. Daily updates of the average temperature over the whole region. Again, we don't care about the Nino 1.2 region. Just for historical purposes, it's 2.1 degrees, okay? And you can see it was actually quite high there back in the July time frame, kind of has petered out, but still quite respectable. But here are the Nino 3.4 numbers. Current daily value plus 2.278. And if you recall, looking at the previous chart, we were talking about temperatures for the 97 El Nino and the 82-83 El Nino. They were monthly numbers, in the 2.3 and 2.2 range. We are clearly there, and notice the trend has been nothing, slow but steady up. If we can hold in this range for a month or so, that will put us clearly in super El Nino status. And looking at the subsurface profile, we saw piles of warm water underneath the equator, well west of Ecuador. We saw more west winds, a recent westerly wind burst, just piling more warm water into that reservoir. So the expectation is when those warm waters erupt and advect into the Nino 3. Or migrate into the Nino 3.4 region, that these temperatures will at least stay the same, if not get warmer. So the point being, our El Nino is extremely well positioned to be at least in the very strong category as it peaks out, we're guessing, in the December time frame. In fact, let's go take a quick look at the model. In some ways, this is a bit of a joke. The CFS version 2 forecast for Nino 3.4 says temperatures have already peaked out in October at about 2.1 degrees, and they're all on the downswing. We find that pretty much laughable at this point. Here's the uncorrected version. We'll get it centered there for you. It is a little bit better, showing temperatures peaking at 2.5 degrees in November and sort of holding in November, then falling into the December time frame. Now, this is what we're way more interested in. This is a consensus of all the models that do forecasting. This was just published, I believe it was yesterday, and it splits it by statistic average, dynamic models, and the consensus by the CPC. So if you look here, the statistic average shows their forecast of all the statistic models about 2.4 degrees above normal in the November-December time frame. The dynamic models are saying 2.5 degrees. So this one we just talked about is an upgrade from last update a month ago. 2.5 degrees. And then the CPC consensus is right around 2.4, 2.5 degrees above normal in the November-December time frame. And that's exactly what it looks like is going on. So this is exactly what we want to see. This suggests super El Nino status. So to wrap things up real quick, North Pacific coming online. Jet stream looking good. A series of gales forecast for the Gulf of Alaska dateline region. Seas finally pushing into the 30-foot range, aimed well at Hawaii and the U.S. West Coast. Tropical activity feeding it. Interesting system with Olaf, possibly creating southwest swell as well. In addition, small southern hemi background swell still in the mix for the coming week. And then, of course, our El Nino just continues to slowly get its act together, building adding fuel to the fire. We expect it will start supercharging the jet stream in the next month or so, and the storm machine will just take off and we won't look back. The issue will then become how much weather will we get with the resulting swells. The hope is that high pressure holds off the California coast for a little bit, but at some point we know the floodgates are going to go open. We need that to happen. Bring on the rain, bring on the snow, let it all let loose, but at least give us a little bit of clean surf and big clean surf before the storm door opens. But right now things are looking very good. We are on track for near super El Nino status. We will not jinx it by saying it's going to be, because we don't believe it is. It is just a very strong El Nino at this point, looking very good. So that's it for this week. We'll do it again next week, same time, same channel. See you then, and thanks for watching.